Folks, we're just going to give it 2 more minutes before we kick off this webinar series. Just give us 2 more minutes. Thank you. Okay, it's 12:02. Thank you very much for joining today's call. My name's Simon Ibbett. I'm the account executive for K through 12 in Illinois. And we put together this webinar. This is number 1 of 4 that we'll be doing consecutive weeks. You can register for the other at www.azure123.rocks to really have education in what is the cloud and have it in an education focus. There's a lot of these webinars are for enterprise, and I definitely saw there was a shortage of education focused webinars. We want to kind of build a community as well, and going onwards, these will be recorded. The slides will also be uploaded to the website. So again, please use this as a community, and also just to get the interest there. Again, having been in working for Microsoft for 7 years and being in Chicago and Illinois over the last 2, again, we don't always see the best voice out there of what this is, and this is really to give you guys direct access to this type of education. I'd like to introduce Tom Lilly. He's going to be our presenter today, and we're going to start with your journey to the cloud for $100 a month. Over to you, Tom.
Awesome. Thank you, Simon. As Simon mentioned, my name is Tom Lilly. I'm a Microsoft Cloud Solution Architect here at Netrix. Been working with Simon and the whole EDU team with Microsoft, and as well as actually I've recognized some faces on this call as well around Microsoft Cloud Solutions, Azure, EMS, OMS, pretty much that entire stack. So my role is to essentially help solution and design some of these items and make sure that you guys get out of it what you would expect. So if you feel like following me on LinkedIn, feel like tweeting at me, my information is on this contact slide as well. For today, we have a quick agenda that we're going to run through. So we're going to start with talking about the journey to the cloud and why we want to leverage the cloud solutions. Talk about what makes Microsoft Azure a differentiator in the cloud platform. Talk a little bit about the differences between what we refer to as infrastructure as a service versus platform as a service. Talk about certain Azure solutions that we have, and then let's get into the fun stuff. What can you really get for $100 within Azure? And then finally, and that one actually didn't show up, unfortunately, but not only just what can you get for $100, but what can you get for free? Because there are actually several services within Azure that you don't even have to pay for. So as we start talking about IT transformation and digital transformation, all those fun buzzwords that everybody loves today, the cloud, and I'm putting that in air quotes for anybody who can't see what I'm doing, is the next big IT revolution, is the next big strategic opportunity. 10 years ago it was virtualization. 5 years ago it was starting on the cloud side, but really we're at the point today where the cloud is becoming a lot more strategic, is becoming essentially that next big hurdle for a lot of clients. And it's not just it's not the same way that it used to be. It used to be going from physical servers to virtual servers was going to be a big pain because people wasn't supported very well, and the transition process was pretty significantly difficult. Whereas moving to the cloud is becoming a little bit different. There are a lot of organizations, there are a lot of people that are leveraging cloud first, actually, for a lot of things. And that's really what we want to talk about today is how do you use that innovative capabilities of the cloud? How do you leverage Azure to its fullest capabilities to not only present services to users and your students and your faculty and your staff, but how do we actually build first for the cloud? Things like why am I worrying about maintaining SQL servers, or why am I worrying about maintaining my Tapa rack switches and things like that? And that's really where we get into our cross here, is where do IT and the business meet? And a lot of the issues that we run into, a lot of the pushback we usually run into is going to come around cost, which is why we want to start with this presentation here, is to talk about how we can leverage the cloud to, extend our data center to give us capabilities that we wouldn't necessarily have outside of our own four walls while not breaking the bank. So as I kind of mentioned before, today your data center infrastructure is kind of your home. You've got your servers, you've got your networking, you've got all your power and cooling and all that stuff that kind of goes into it. And back in the day, it was all going to be, it's all physical servers. We need a SQL instance, therefore we buy a server. We need a domain controller, therefore we buy a server. We need an application, therefore we buy a server. A while ago, that shifted. We're now seeing a pretty significant decrease in physical infrastructure. Obviously, some is still required, but a pretty big shift toward virtual infrastructure. And a lot of the reasons behind that was for server density as well as increased ROI. If I have one server that's got X amount of capacity, and I'm only using 5% of that, the other 95% is essentially being wasted. I bought this hardware, it's not doing anything for me. What virtualization allowed us to do is to increase that density of those virtual machines within the data center and to better utilize that capacity. And things like storage area networks and vSAN and some other things allow that to help as well. Well, as we start to talk about the cloud, we're kind of in that same revolution as I was mentioning before. So now, not only do we have the ability to increase density and remove the necessity of leveraging on-premises resources, but we can also scale out into things like PaaS, Platform as a Service. And then we also have our more traditional IaaS, or Infrastructure as a Service. And there are a lot of questions that we usually get out of this. Great, we're virtualized. We're taking advantage of our infrastructures as much as we can, but there should be more to this. How can we further reduce administrative overhead? How can we increase automation? How can we increase performance at the same time? How do we work around things like DC constraints or data center constraints? Hey, we don't have a lot of extra capacity in our data center unless we want to add 2 additional nodes to our cluster, which could be a significant capital expenditure. How do we deploy some of these services? The other thing that we run into a lot is business groups already using it. I can't tell you how many clients, both on the enterprise and the education side, come to me and say, listen, our developers are already using something like Visual Studio Team Services or VSTS. They already have their own free Azure accounts and things like that. So, if they're already using it, how do I rein that in? How do I make sure that they're using it the way that we want it to be used? And that all comes into the cloud. And the last one that I do want to point out here is making a shift toward the cloud, making a shift toward, the software as a service, platform as a service, infrastructure as a service model doesn't necessarily mean a one-for-one shift. It could be that, our server provisioning process today takes 6 weeks because we need to do X, Y, and Z. When we shift to the cloud into something like infrastructure as a service, maybe we get rid of X and Y and we only do Z because the other two are being handled for us. Now, the interesting thing about that is that's not necessarily going to be a decrease in a hard cost, but that's going to absolutely decrease soft costs. And as we start talking about how do we optimize IT departments, how do we optimize how you leverage these services, it's not always about that hard cost, the cost of the hardware, the running cost of your virtual machines in Azure or your SQL PaaS instances. If I'm an administrator and now I spend 2 hours a week versus 8 hours a week administering some of these services, then that translates into more time for me to take other strategic initiatives or address other tactical initiatives and make sure that I am essentially working the way that I should be. So I've thrown around a few acronyms just to kind of go through a quick breakdown of what we're talking about today. One of my favorite slides of all time, just because I enjoy pizza, and I think it's a pretty good way of looking at how we separate out IaaS, PaaS, on-premises, and SaaS. As we look at on-premises infrastructure, you are literally responsible for everything. My hosts, my power, my cooling, all of my warranties. If a disk fails on my VMs, my physical security, my swipe access, things like that. For on-premises, you are responsible for 100% of it, whether you want to be or not. I have a lot of clients that are looking to get out of the data center business. The next step up from that is what is referred to as infrastructure as a service, or IaaS. Now, with IaaS, we obfuscate a lot of that underlying infrastructure. You don't have to worry about patching your host, don't have to worry about the physical security of the data center, don't have to worry about things like your top-of-rack switches. At the same time, you're still responsible for things like patching your virtual machines, making sure that your middleware is on and in the correct version for your applications to run, etc. If you want even less to do with your services, the next level up from that is what's known as PaaS, or Platform as a Service. Platform as a Service actually completely obfuscates that virtual machine in the middleware. So, for example, I'll show this later, with SQL PaaS, I can essentially say, I want a SQL server. Give me a SQL server. And I can actually deploy that with just a few clicks, and at the end of the day, I have a SQL server. I can still manage it using my tools like SQL Server Management Studio. I still get my ODBC and PHP and Java strings to connect to it, but I don't have to worry about patching SQL Server. It's natively highly redundant as well, or I can even do geo-redundant if I want to. For anybody who's ever had to set up things like database mirroring or always-on availability groups, log shipping, etc., you know that it can be pretty difficult to get that kind of dialed in. Whereas with something like SQL Platform as a Service, I click a couple buttons, and at the end of the day, I have a highly available platform instance that I can leverage just like I would a SQL Server on premises. And then the last tier on that is Software as a Service, or SaaS. For anybody who's using Office 365, that's going to be the easiest analogy I can make there, is Office 365 is software as a service. I don't care about my Exchange servers. I don't care about my SharePoint servers, my Skype for Business Online servers, etc. That's all being handled by my provider. All that I am responsible for is essentially the data that I put out there, as well as certain security controls to make sure that your environment is as secure as possible. And then that kind of maps over to pizza as a service, as we have all the way from traditional on-premises, which is you make the pizza from scratch, all the way up to our software as a service pizza, or pizza as a service, which would be fantastic, which essentially I go and I actually just dine out on pizza. I don't have to worry about literally anything. Once again, we will make this slide deck available for those of you who want to read through pizza as a service a little bit more. Like I said, it's one of my favorite things. So as we start talking about Azure services, this slide has a lot of things on it. I'm not going to talk about each one of these because we don't have the 6 to 8 hours to just start diving into some of these. What I want to focus on are some of the low-hanging fruit, and that's going to be a lot of the infrastructure services. What are the easiest ways to get you guys up into Azure? What are the easiest ways to do a data center migration or start extending your data center into Azure and leveraging some of these services? So because of that, I want to focus on just a few of these, specifically around things like security and management. The number one comment I get is the cloud is insecure. Well, let's talk about that here in a little bit, and the $1 billion that Microsoft is investing per year just on cloud security. Things like hybrid cloud solutions. How do I integrate my on-premises cloud into Azure? And then some of the more basic components of infrastructure as a service, so compute, networking, and storage. So let's talk a little bit about Azure. This slide is actually a little bit out of date. For anybody who keeps on top of Azure news, they actually just literally yesterday announced a brand new data center in Canberra in Australia, as well as data centers in the Middle East, as well as in Africa and a few other regions. So right now, Azure is sitting at about 46 regions or so, with that number expected to grow even further. For you guys who are more education focused, my assumption is that the majority of you will be deploying within the United States, in which we have about 10 to 12 regions. But for any of the higher education organizations that maybe service students all over the world, this actually gives you the capability of deploying applications and services campuses near to your worldwide students without having to purchase data center space in, say, India or in Japan or even in South America or Canada. This gives you that capability to extend your data center into other regions as you see fit without having to make that capital expenditure. The nice thing about these regions is all of these regions are paired for geo-redundancy. So as we start talking about how do we make sure that my data is always available, within Azure, we'll say US East, which is located in Virginia, US West, which is located in California. These regions are actually paired so that if one region goes down, you have the capability of actually failing over your data to another region. Or when Microsoft performs planned maintenance in one region, you actually get the capability of, the way that they orchestrate it, they actually ensure that the other region is not put under maintenance at the same time. So now as we start talking about making sure your applications are highly available, we can actually deploy in multiple data centers, keep them in sync, and ensure that everything that you have is always up all the time. Within these regions, we also have the concept of things like availability sets and availability zones. That we actually support a 99.99% SLA on virtual machines. For storage, and I just found this out the other day, which I thought was really cool, Microsoft actually supports 16 nines of availability of storage within Azure for geo-redundant storage. I don't know what that translates to into downtime per year. I'm pretty sure it's in the order of milliseconds, if not less. But that is actually documented. If anybody wants to look it up, it's 16 nines of availability as we start talking about storage within Azure. I don't know about you guys, but I do not have any, I know that my data centers cannot support 16 nines of availability on anything, let alone storage. One of the other things to keep in mind is that Microsoft actually maintains one of the largest networks in the world. I think they're number 2 right now. They actually have 1.6 million miles of fiber laid all throughout the world. That's not only within regions, but that's also transatlantic and subsea cables. So for example, if anybody is familiar with the Maria cable, it was a joint venture between Microsoft, Facebook, and a Chinese telecom company to actually lay a brand new transatlantic fiber between the United States and I believe it was Spain. The issue that we run into is a lot of transatlantic fiber terminates at one given location. Microsoft decided that, hey, this is probably a pretty bad idea because if these locations go down, we are kind of out of luck. So what they did is they actually laid down this Maria cable, and I think it supports something like 60 terabits per second of throughput on that cable. So pretty significant. As we start taking a look at this network, we have things like data center locations, which are these red dots. We've got edge nodes, which are where you can get into the network, internet exchanges for BGP route redistribution, etc. Not going to get into all that, but just keep in mind that Microsoft does maintain one of the largest networks in the world. And with some recent announcements for things like global VNet peering, you can actually allow your Azure networks to talk directly to each other over Microsoft's dark fiber without having to traverse the internet at all, even with a site-to-site connection. In addition to that, if you don't want your traffic to go over the internet at all for security reasons, performance reasons, etc., Microsoft offers what's known as ExpressRoute, which is direct private connectivity up to 10 gigabit per second up into Azure. So now, if you have applications that are very highly performant, very dependent on network latency, things like that, what we can do is we can configure ExpressRoute and actually put, say, an application tier up in Azure, put a database tier back on premises, and get reliable latency and performance between the two tiers. This also, as I mentioned before, gets you that private connectivity. So now I don't have an IPsec tunnel going over the internet. I actually have a direct connection to my MPLS or through, say, one of my providers that I've worked with. This is a small subset of the providers that support ExpressRoute. You'll see a bunch of familiar names on here like Level 3 and Equinix. Also companies like Verizon, NTT Communications, Comcast, AT&T, Zayo, etc. So if anybody has a WAN provider today or is looking at a WAN provider, there is a good chance that they're going to be on this list and be able to support ExpressRoute for that direct private connectivity. As I mentioned before, we usually talk about security within Azure, and I kind of said it is that the number one question I always get is, well, how secure is Azure really? Well, let me show you. As we start talking about the compliances that Azure maintains, here is just a smattering of what they have. Things like PCI DSS 3.2, SOC 1 Type 2, SOC 2 Type 2, ISO 27001 for just the industry standards. We also have very specific United States standards, FedRAMP, FISMA, HIPAA, HITECH, FIPS compliance, as well as regional compliances for other countries like Germany, the European Union. Anybody who's looking at GDPR, the brand new EU General Data Protection Regulation, Azure is GDPR compliant, and they will maintain GDPR compliance for their data centers because they have to. If they don't, then no one's going to want to put their data in there. This is just a small subset of those compliances. Microsoft actually publishes what's known as the Azure Trust Center that lists all of their compliances per service. So you can look and see, hey, if I want to use Azure Log Analytics for monitoring, I want to use virtual machines, I want to use storage, what compliances do those maintain, and how do I ensure that my data is secure? Microsoft maintains all of that information within the Azure Trust Center itself. But if you guys are ever worried about how your data is being stored within Azure, this list here should be able to hopefully make you feel a little bit better about how they're securing your data. As I mentioned before, Microsoft has committed for the last 2 years and has committed for the next fiscal year to invest at least $1 billion, and that's billion with a B, in cybersecurity for Office 365 and Azure both. As we start to talk about trust within Azure, it really comes down to defense in depth. Anybody who has anything to do with security should be pretty familiar with defense in depth. It's not just a one and done. It's not just, hey, let's put DDoS prevention at the edge and be done with it. It's really a multi-tier, multi-layered approach toward making sure that your data is safe. So everything from the physical layer, having 24/7 armed staff, having barriers, fencing, man traps, days of backup power if they ever do suffer a power outage, multiple ingress and egress for their networking infrastructure, etc. We start there on the physical side and move into the infrastructure. So things like security by design, making sure that their infrastructure is compliant, regular pen testing, DDoS prevention, etc. And then all the way down into the virtual machine side of things. Now, one thing to keep in mind is that you guys are still responsible for your own virtual machine security, but Microsoft makes certain things available to you. So things like being able to automatically install anti-malware, doing key vault for secret storage and things like that. You get that with this as well, and that capability of ensuring that your services are being secured. And that leads me into what's known as the Azure Security Center, ASC. The Azure Security Center is essentially a dashboard that you can look at within Azure to get an overall holistic view of how secure is your environment. So things like, are my storage accounts encrypted? Are my virtual machines using disk encryption? Do they have anti-malware installed? Even to things that are a little bit more on the heuristic side. Do we have is one of my accounts getting brute forced right now? Are my virtual machines talking to a malicious IP because it's part of a botnet? Do I have a malicious IP that's talking to one of my virtual machines because it's trying to gain access to one of my accounts? You actually get this view within Azure, and you don't really have to worry about deploying your own monitoring solution or things like that. Now, it's not to say you can't do that. We have a lot of clients who decide that they want to continue using their own monitoring solutions, but this is built into the service and kind of gives you some of that infrastructure and platform level security that you may not necessarily get by integrating with things like a Splunk or other on-premises monitoring solutions. One of the other big questions I get is, well, what if we don't run Windows workloads? Well, let's talk about Azure being an open cloud. So this is, once again, just a subset of the third-party non-Microsoft services that are supported on Azure. Everything from Nagios, Chef, Puppet for desired state configuration, WordPress, Joomla, all the way down to the infrastructure level. Hey, we run Red Hat, we run SUSE, we have our own Oracle databases or FreeBSD, or we want to use Docker and not Nano Server for our container instances. We have all those capabilities within Azure. Now, the one thing I always like to say is that Microsoft is not in the Steve Ballmer era anymore. Back in the day, for anybody who followed Microsoft back when Steve Ballmer was at the helm, it was very much Microsoft first, and Microsoft only. Microsoft essentially did a big 180 when Satya Nadella took over the reins. Is his whole thing is, yeah, Microsoft is great. I want people using Windows and things like that. But at the same time, I want to give people a good experience. I want people to be using Windows and Azure and all that as a platform, not just our services. And so one of his very big initiatives was to open up Azure and make sure that everything, that third parties could leverage it as that open solution without having to be locked into the Microsoft ecosystem. And that's essentially what he's done, and this slide is a great indicator of that. And for some of these solutions, you may not even know where to start. I don't necessarily know how to deploy a Hadoop cluster, or deploy Puppet or Chef and all the recipes that come with those. But what we have within Azure are actually pre-configured services or solutions, where to say, hey, I want to deploy SharePoint Farm on Azure. I don't want to spend the entire time deploying my SQL servers and deploying my app servers and my web front ends and doing the configuration and tying them all into everything. We can actually deploy solution templates within Azure to show or to deploy these things per best practices. And that leads me into infrastructure as a service. There are three primary components to IaaS. We have compute, storage, and networking. Anybody who's run a data center, anybody who currently operates a data center should be pretty familiar with IaaS and all three of these components. And then obviously the important piece on top of that is going to be the management side of things. How do we deploy these virtual machines? How do we monitor these virtual machines? How do we make sure that the right people have access to them and can turn them on and shut them down? So I want to start on the compute side and really start with some of the differentiators within Azure. The number one, probably not the number one question I get, but I have a lot of clients that are doing a lot with GPUs, whether it is to present things like Autodesk or Revit to their users, to be able to do 3D modeling, things like that. But a lot of clients that do things with artificial intelligence, machine learning, fluid dynamics, etc. And what we can do within Azure is we actually have what's known as the N series of virtual machines. The N series of virtual machine is, the N stands for NVIDIA, is we actually pass through an NVIDIA GPU, either one that's dedicated for compute or one that's dedicated for rendering to that virtual machine. So now if you guys have architecture labs or you have third-party services that do weather modeling or that fluid analysis or any of those research departments, you don't necessarily want to pay for a pretty significant infrastructure to support NVIDIA GPUs for kind of that hyper-threaded, multi-threaded processing. You can spin up these servers within Azure and just turn them off when they're not being used. The nice thing about these virtual machines is you only pay for them when they're in use. These GPUs are going to be the P100s and P40s. They're going to be the latest generations, and actually there is a V3 that's not represented on this slide that has been released as well. So you can actually, once again, turn these VMs on, run a couple models, do what you need to do with them, enable them for a student lab, and then once again turn them off and not have to pay for them. And that's going to obviate the need for that capital expenditure to buy those GPUs. One of the other things that I do want to say on that side as well is Microsoft has partnered with Cray supercomputers. So if you guys have any workloads that would benefit pretty highly from a distributed computing platform like Cray, you don't have to necessarily buy or rent your own, go straight to Cray and rent that computer. Actually do that straight from Microsoft and have that as part of your Azure commit, which is pretty slick. For anybody who uses Oracle, and I'm sure that's a pretty big subset of you, Oracle is licensed based on CPU cores. Well, if I have a virtual machine that I need a lot of CPU cores to run a specific batch job or things like that, but I don't necessarily want to allocate those cores toward Oracle, I can actually deploy a partial core virtual machine. So now, instead of the full 32 cores or 64 cores or 128 cores that I would then have to license every single one of those for Oracle, I can take that and just say, well, maybe I only need a half of those. Maybe I only need a quarter of those. And now I pay a pretty significant licensing cost, or pretty significantly reduced licensing cost for my Oracle and SQL databases, because I don't have all those cores being presented to the virtual machine. So that's one way that we can additionally cut costs and save on some of these items within Azure. One of the other ways that we can ensure that we get the performance we need while saving money is by using what are known as burstable or B-series VMs. Essentially, what happens is that these VMs run at a lower clock speed most of the time, but they have the ability to burst into faster tiers. So if I have just a VM that's running a steady state, and then for 10 minutes out of the day or 30 minutes out of the day, I need more CPU to run a batch processing job or do something along those lines, I can use these B-series VMs, which are at a lower cost, but now they have that capability of bursting into the higher CPU level. And then based on that, I can, once again, make sure that cost remains relatively low while still giving me the performance when I need it on this specific virtual machine. This has nothing to do with saving cost. I'll be perfectly honest with you guys. I just think it's really cool. Microsoft actually deploys SAP HANA dedicated instances within their data centers. These are large instances. These are actual physical servers within the data center. These servers have 960 CPU cores and 20 terabytes of RAM per server. That's a pretty big number. I think this is literally the largest virtual machine, or sorry, the largest server available in any public cloud provider. But for anybody who's running SAP HANA and doing a lot of OLAP or OLTP, you know that you need a pretty significant amount of processing power, pretty large amount of memory to cache a lot of the information on the virtual machine, or on the server itself. Sorry. So here is, that option for you. Once again, I don't have to have that giant capital expenditure to buy this size of server for my data center. It's something I can rent from Azure. And once again, just like everything else, this is billed by the minute. So if I need this size of virtual machine, but maybe only for a couple hours out of the day, maybe only for a couple hours out of the week or month, I only pay for that for the time that it's on and actually doing work. Otherwise, I shut it down. We can even automate that shutdown. You don't have to pay for it, which is a great way to save costs. In addition to compute, we also have storage. So just like most other cloud providers, we have the concept of what's known as a storage account. This storage account supports a lot of different protocols. So things like blob storage, which, if anybody cares, stands for binary large object. We have table storage, which is for non-relational data, queues for message queuing, as well as file storage, which is direct SMB access. So now we can actually take data, replicate it into Azure, into an SMB endpoint, and now you don't have to worry about users accessing a file server on premises. Now that they can actually access an SMB endpoint directly out of Azure. For any of your high-performant workloads that need a lot of disk performance, we also support premium storage, which is backed by SSD. For any workloads that don't need that level of performance, we actually support spinning disk or standard disks that are going to be limited to 500 IOPS. So once again, we can right-size these environments to match what your needs are. From an infrastructure perspective, we primarily talk about these three services, blobs being block blobs, premium disks, and standard disks, which are referred to as page blobs, then Azure File Storage, which is just that SMB endpoint. One of the things that was released about 1.5 years ago is the capability of supporting larger disks. So if any of you are running virtual machines on premises that have large disks, think over 1 terabyte, our new max size for disks is actually going to be 4 terabytes. Now, I don't want you guys to confuse this with volumes. You could have multiple disks that are striped into a single volume. As long as the individual disk does not go over 4 terabytes, technically it's 4,095 gigabytes, then we can actually replicate that disk in Azure one for one. Now, if you do have disks that are larger than 4 terabytes, that's something we would have to address and probably break them up. But at the same time, I don't think I've run into any clients yet that are running disks that large. On the flip side, we have the capability of using small disks. So it used to be that the smallest disk you could get was 128 gigabytes. And if you had that on a solid state disk, that may have been overkill for some of your workloads that may not be large, but maybe need a large number of IOPS. So what we have now is actually the capability of leveraging small disks. So once again, we can save you money by not deploying a 128 gigabyte disk, but only deploying a 32 gigabyte disk. And now that 32 gig disk is going to be $4.80 a month versus the almost $18 for that P10 or that 128 gig disk. We do also support larger sizes for premium storage accounts as well if you need that level of performance as well as that much storage. We also have virtual machines that are explicitly deployed on small disks. So if you have that workload that you want to deploy, but you want to make sure that you reduce the storage cost because you don't necessarily see the C drive growing in size, you don't necessarily see a data disk growing in size, you can use these small disk templates to make sure that you get deployed the way that you, based on the sizes that you need. And then one other thing that we can do as of late is actually support nested virtualization. So one brand new thing that's in Windows Server 2016 is that HyperV now supports nested virtualization. Essentially means that I can run a HyperV server within a HyperV server within a HyperV server within a HyperV server. There are probably very few cases in which you would want to do that, but if you need an extra level of isolation for your virtual machines, you don't want to use one of the isolated instances within Azure, you can just spin up an EV3 or a DV3 series virtual machine and install HyperV on it. Well, now we can set up HyperV replica between your on-premises environment and within Azure. You can give those hosts to your student labs, and your students can spin up their own dedicated environments within that HyperV instance. And then once again, we shut these down when you don't need them. You don't have to worry about paying for them because they are billed on a per minute or even per second basis. And one of the other things that we have available is accelerated networking. So if you have any of those workloads that are very reliant on networking, we leverage what's known as SRIOV, or single root IO virtualization within the virtual machines to directly present the host NIC to the virtual machine and actually decrease latency significantly and increase performance to up to 30 gigabit per second, as you can see here. I've actually heard rumor that this is even being increased to about 60 gigabit per second on some virtual machines. So the big takeaway from this side of things is really going to be around, the fact that we can right-size these workloads to, once again, control costs where they need to be, but still give you that predictable performance that you would expect. On the Azure networking side, there are a couple different ways that we can provide for networking access. So number one, users can go over the internet if you really want them to. Think about presenting a website or any other service that doesn't necessarily have stringent security risks. You can have users go in, RDP over a public port, and now wherever they are in the world, assuming you allow them to do so, they can get access to their resources. Once again, as we start talking about things like student labs, if students are out on spring break or fall break or things like that, maybe they go home to another country, maybe they go home even to another state, and they want to gain access to their resources. You can grant them that access within Azure without having to open up your firewall to having users VPN and etc. For some of that dedicated connectivity, we have that capability of doing VPN gateways for site-to-site connectivity over IPsec. And then we also have ExpressRoute, as we talked about before, for that direct private, low-latent, high-performant connectivity between you guys and Azure as needed. So there are a bunch of different ways that we can provide for that access. Once again, this is something that we can tailor to a given environment and get deployed to make sure that we are working on it and deploying what you guys need as you need it. On the management side, one of the things that we absolutely want to talk about is the new version of Azure, Azure 2.0, which is called Azure Resource Manager. So the nice thing about ARM is every single resource within Azure is defined within what's known as an ARM template, which all it is a JSON JavaScript object notation definition of a resource. So as we start deploying resources, we can actually set up configuration compliance. We can repeat this process pretty easily by using ARM templates. So we deploy a virtual machine, deploy a SQL server, deploy a storage account, deploy a web app, whatever. But now we can take those, put them in what's known as a resource group, which is essentially just a logical container. And now if I have that lab environment for my students, or I have a specific set of virtual machines that I present to my IT staff, I can templatize that and actually automate that deployment. So now my users maybe go into a portal and say, I need a virtual machine. I need a 3-tier application. I need a web server, etc. They can go there and request that. We can automate that deployment process without having to involve the general IT staff. Or maybe we still involve IT for things like approval processes, for validation, etc. So once again, we start talking about not only controlling those hard costs of, buying that infrastructure, maintaining that infrastructure, but also those soft costs of how do we leverage our resources more effectively from a personnel perspective? How do we ensure that our IT administrators are leveraging these services and able to, work efficiently from a day-to-day basis? So I want to go through two quick demos real quick, really to talk about how do we how do we provision virtual machines, as well as how do we actually provision something on the platform side, being a SQL database. So those of you who haven't seen this before, this is the Azure Portal, portal.azure.com if you're curious. From a virtual machine perspective, all I really need to do is go ahead and add a virtual machine. So what it's going to do is it's actually going to present a bunch of different options. So we talked about Azure being an open platform. Do I want to deploy Rail? Do I want to deploy Ubuntu? Do I want to just deploy a regular Windows server? Or I have these images. Do I want to deploy a Commvault server, a Veeam endpoint? Do I want to deploy something like Teradata Viewpoint? Do I want to deploy a Cisco ASAV or CSR 1000V for a networking device? I have all these capabilities. It's not just going to be Windows Server. In the interest of simplicity, I'm going to go ahead and deploy a Windows Server, though, because I'm sure that's what most people are going to be pretty familiar with. This is going to be a very wizard-driven deployment process. So for example, I'm going to go ahead and give this a server name. This name can be anything. The cap is going to be the NetBIOS cap, which is 15 characters. I choose whether I'm going to deploy hard disk or solid-state disk. Go ahead and give it my local admin username and password. I'm going to go ahead and say use an existing resource group for now. And then we also have the capability of leveraging what's known as Azure Hybrid benefit. For anybody who maintains Windows Server licensing on premises with software assurance, you can actually deploy Windows virtual machines in Azure without paying for the Windows license. That's what's referred to as Azure Hybrid benefit. For educational institutions, usually you guys get a pretty significant break on Windows licensing, more so than we see on the commercial side. So in a lot of instances, it's actually more cost advantageous for you to purchase additional Windows licensing on premises and just applying that license to a Windows virtual machine. And literally all it is here is a toggle that says, do you have a Windows license? Yes. And then just Microsoft's quick CYA, yes, we have we actually have that license. The next step here is going to be sizing the virtual machine. So I'm going to go ahead and view all here. So the interesting thing here is that this is going to show me what the monthly pricing is for any of these given virtual machines, so that I can see that for an A1 standard virtual machine, which has one CPU, or now that it's refreshed, for my D8S V3, so 8 CPUs, 32 gig, the running cost a month, assuming it's up for 24/7, is $285.70. Well, maybe that's a little large for what I need. Maybe I just need a D2S V3, which I can see is a much more modest $71.42 a month. I'm going to go ahead and select that one. So any of these sizes, and I'm going to scroll through this list quickly, these are all the capabilities and sizes that we have within Azure. You see that we have some that are not available in this given data center because of the lack of infrastructure. But I choose one of these, I select it. I'm not going to step through everything in here, but essentially where I go from here is I say, where is my storage going to be located? Do I want this to be an availability set so it's highly available? What network is this going to be attached to? Is this in my DMZ? Is this in my backend network? Do I want to ensure that I have a public IP, things like that. That's all done from here. You can see it's very wizard driven. It's very simple. And then what this is going to do is about 15 minutes later, it's going to go ahead and get this virtual machine deployed, and now it's complete. And then if I wanted to, I could actually go into any of my given resource groups, and we'll use my Azure to Azure source. And I actually have this button here for automation script, and that's a bad one because that one is empty. Within this resource group, I have my automation script here. I can click on this and actually get the entire JSON definition of my Azure resources. So this is probably going to look a little Greek to people who haven't looked at JSON templates before, but this is actually the next step toward what's known as infrastructure as code. From a SQL database side, from a platform perspective, it's going to be even easier. Is that all I do is I say I want to create a SQL database. I say, what's the name of the SQL database? Say that's Azure 123. Am I am I creating this from a blank database, a sample database for anybody who's familiar with AdventureWorks, or just a backup from another database? What server is this going to be hosted on? I already have a couple SQL platform servers, and we'll toss it on this guy here. And then what's the pricing tier? So once again, I can click here, get information on what this is going to cost me, and size this appropriately. So I can see that my DTUs, or for 100 DTUs or an S3 instance, it's about $150 a month. Well, maybe I don't quite need that. Maybe I just need 20 DTUs and it's going to cost me $30 a month. So, this is that capability that we have to kind of run, have these rolling sliders to get this size the way that I want. And go ahead and apply that. And then once again, all I do is I hit the create button. And now I have a SQL instance that I can manage through SQL Server Management Studio. I can connect to using connection strings, etc. So I'm going to skip ahead a little bit in the presentation. And this gets to the point of, for $100, what can I really do within Azure? Because once again, the big perception is Azure is expensive. There's no way that I can actually do anything meaningful within Azure for $100. Well, let's take a look. So these are all based off the Azure pricing calculator. This is subject to change, so some of these may be out of date. But I can actually run 4 full virtual machines within Azure for that month for under $100. Do things like upload 4.8 terabytes of hot locally redundant storage. So now if I need to offload data, I can do that almost up to 5 terabytes for under $100 a month. Stand up those 6 standard SQL PaaS databases, 250 million DNS queries for a single DNS zone within Azure, just over 1.1 terabytes of content delivery network within the entire world for you guys who run your own CDNs, 4 terabytes of data backed up from an on-premises server, 4 on-premises DRs, or DR for 4 on-premises servers, 100 million push notifications from an event hub, 800,000 IoT messages a day, 43 gig of log analytics data for monitoring, 50,000 minutes of automation within Azure Automation for PowerShell, 1 app service if I want to run a platform as a service web application. If I really want to go whole hog, I could even provision a G5 virtual machine that has 32 cores and nearly half a terabyte of memory and 6.2 terabytes of local SSD for 12 hours. Once again, I shut it down, don't have to pay for it all, and I don't really have to worry about it. Or if you guys are doing anything with data lakes, for multiple disparate data sources being stored in a single repository, I can actually get 2.5 terabytes of data lake data with 100 million transactions to query that data, update that data, etc. So if you guys are starting to dip your toes into the big data space, this is a great way to do it. Now, this isn't every single thing that we can do for under $100 within Azure. This is just a small subset of things that we see a lot of clients talking about, a lot of initiatives on that side. But what's even better than doing something for under $100? Well, Microsoft actually has a set of services within Azure that are completely free. You don't have to pay for them. You don't even really need to sign up for a real quote-unquote Azure subscription. These are all free services for all time, and you can leverage these just right out of the gate. So things like leveraging 1 million function requests, which are for serverless compute. Orchestration around service fabric and container services. So if you guys are looking at Azure Container Services, we can actually orchestrate those for free. You don't have to pay for that service. 500,000 users in Azure Active Directory, 10 free app services on a monthly basis. For anybody who's using machine learning around API integrations for natural language detection, face API, you actually get 30,000 face API transactions per month as you start looking at things like emotion APIs and are people happy when they're in the classroom or as they're walking down the halls and things like that. These notification hubs, 1 million push notifications, orchestration around dev test labs to automatically start up and shut down virtual machines. If you guys are doing anything on the machine learning side of things, you get 100 machine learning modules per experiment for free. Don't have to pay for it all. The big one I like to talk about is Azure Advisor. Even if you do have paid services within Azure, you can leverage Azure Advisor to do things like right sizing, get better information about your environment, and make sure that you're running optimally within the cloud. And for anybody who's doing any sort of monitoring, we also have the capability of uploading 5 gig of log data per day. We start talking about Windows event forwarding, performance logs, things like that. We can actually take that data, ingest it into what's known as Azure Log Analytics, and affect that 5 gig of data per day. I see a lot of clients who are looking at a cloud-based monitoring platform, starting with that free tier. I essentially toss an agent on a virtual machine, start uploading data. As long as it's under 5 gig of data, then I don't really have to worry about it. So as you can see, and once again, this is just a subset of services. The full list is here down at azure.com/free. That's going to be the full list of free services, as well as some of the things that Microsoft gives you for free for the first month. But this by no means is an exhaustive list of some of those free services that we can leverage. So from my perspective, that's all that I really wanted to talk about today and kind of demonstrate as part of this. At this point in time, I'd like to open it up to any questions. Anybody who is in the Skype meeting, if you want to paste or toss them into chat, feel free to do so. If you guys have any other questions or comments, please feel free to toss them in there now.
I'd also like to take this time just to remind people that this has been recorded and will be posted on our Azure 123 On Demand YouTube channel, as well as being the slide decks and the recordings will be on the website, the Azure123.rocks website. I think we've got one from Anthony. Yep, absolutely. That's the point. And again, just to reiterate the point of why we're trying to put these webinar series together. This is education. This is to make sure that you guys understand what's available and again, get that community. I would like just to also remind that next week's webinar is will be at 12 to 1 Central. It's be backup and disaster recovery. Certainly in the 53 school districts that I run, this is a very big question. This is a very easy step to get going.
Yep. Yeah, thank you very much for that, Simon. And I do want to address, Justin, I really appreciate your comment in chat about developers. This talk today was very focused around the infrastructure side of things because that's where we see kind of that low-hanging fruit. There's a lot of enablement for developers within Azure around CI/CD, so continuous integration, continuous deployment. For anybody who is familiar with CI/CD pipelines, Visual Studio Team Services, things like just implementing direct API endpoints and adding in security through Azure AD natively, things like that. So, I don't want you guys to take away from this that there is, Azure is really just an infrastructure platform. There is a lot of development and development capability that goes into Azure as well. And actually, the session that we have after next week's, the one that's going to be on April 17th, is going to be focused around app dev and some of those capabilities within Azure. So if you guys have a development staff, if you guys are developers yourselves, or just want to learn more about what Azure can do for you from a dev perspective, please join us for that April 17th session as well. So from my perspective, I think that is about it. I don't see any other questions coming in. Cool. Thanks, Anthony. I'm going to say I don't see any other questions. Are all tools available to students? So that's going to depend on your Azure agreement. You can make any of these tools available to your students based on what your policies are to kind of tailor it to what they want, because the last thing we want is students spinning up one of those SAP HANA VMs and costing you a bunch of money. So there are ways that we can restrict that, but to the best of my knowledge, that's absolutely something that we can make all of this stuff available to your students as part of their labs, as part of their courses, etc. Simon, if you have anything else to add on that, I saw you came off mute there.
Yeah, that's probably one, Anthony, to take offline. I know you've got obviously kind of a unique situation at city colleges. So let's take that one offline and we can do a whiteboarding session with Tom and dig a little deeper.
Yeah, absolutely.
Again, this will be recorded. It will be up on the website. I hope you guys have enjoyed it today. Thank you for taking the time out. We hope it's been informative and you found it of use. We look forward to seeing you next week.
Yeah. Thank you very much for everybody for joining.